Okay, in this lesson we're going to look at solving linear equations. Now firstly let's establish our understanding of linear equations. Now firstly, equations have got these things in them, these equal signs. We have been looking at expressions, which are just expressions, just a bunch of terms, and we need to do some simplifying here. We've got an equal sign, so they're called equations. Okay, so with equations we solve. So that's the equation bit of it. The linear bit of it, as is stated here, maximum power of x being 1. So if you have a look at what you're doing is you're solving it for an unknown. So the unknown in this case is x, and the maximum power in this expression is 1. There's a little 1 there, isn't there? We don't write it, but that's what it is. So that's called a linear equation. Just to differentiate it from what's called a quadratic equation is when x has a power of 2, and so we might be solving that, and there are up to 2 solutions. A cubic equation looks like this. A quartic equation looks like this. This is a linear equation, power 1. Okay, that's worth knowing, and the language is important. So we're solving equations that are linear, x power of 1. And the thing about linear equations is that they will have one solution or 0 solutions. So this is worth noting, and I'll just pause while we take that note. Okay, so back to it now. I've just drawn up a little table here that summarizes what I was just saying. So linear equations are equations that contain a maximum x power of 1. Power index means the same thing. So as I was demonstrating, power 1 here means that this is linear. This is the highest power. If we've got an x squared and an x, let's say, you'll see sort of equations like this. Not too far down the track. It's the highest power that defines what sort of function, what sort of equation or expression it is. So the highest power here, that's a 2, that's a 1, is the 2. So it is a quadratic expression or equation, and the maximum number of solutions to the equation would be 2. Okay, so go back up to the table. So the highest power of 1 is called linear, and the maximum number of solutions is 1, and it goes down as like so. So they're good for your notes. Anyway, let's do some solving now. Let's go through some examples, and what we'll do is we'll look at, I guess we'll increase the difficulty. So if these are pretty straightforward examples, and the last couple will be quite difficult, and that's how the exercises, when we get down to 1C, that's how they'll progress. So initially, and I'd expect these to be quite straightforward, although everyone's got different methods as well of doing them. I'll show you what I think is the best method. Okay, what we want to do is we want to isolate the x's, get the x's on their own. So I want to hold the 4x on the left hand side. I use these therefore dots. I write 4x, and what I'm going to do is I'm going to take this 5 here. I don't want it there, I want it on this side. I want to drop it onto the right hand side. Now a really important rule here is when you do that, so the 4x stays on the left side, 17 stays on the right side, but the 5, he's transferred, hasn't he? He's transferred across from the left to the right. So he changes sign when that happens. So change sign when you change side is the sort of the way it's said. So this is going to make things easier for us, because now I've just got 4x on the left and 12 on the right, and then the last step is to divide both sides by 4 and get x equals 3. You divide by 4 because this is 4x and we want x. We need to do the opposite of what has already been done to the x. 4 times x, divide by 4, unravels that, dissolves the 4, and we've got our solution. Let's go over here to this one. First thing we need to do here in this case, I think, is to expand this 3 through. So we write therefore. The therefore dots just give us just a little connection from one line to the next. So 3 times 2x, which is 6x, 3 times 5, positive 15, so I write plus 15 there. Okay, equals 4x. You tell me what you think the next stage is. Absolutely right. I've got what you need to do is pick and drop at this stage. I'll sort of say, well, okay, I want my algebra on one side and my numbers on the other. I'm going to choose to gather my algebra on the left because that's where it'll be positive. If I took the algebra over to the right here, the 6x would be minus 6x. So I'd have minus 2x. I don't want minus 2x. I want a positive x. That's the most important thing for me, because that'll make my calculations easier. So he's coming over this side, the 15. Remember to take the sign with it, the plus 15. He comes this side and becomes minus 15 over there. So let's rewrite this. 6x stays. 4x joins in, becomes minus 4x. 15 gets shoved to the other side, becomes minus 15. So now tidying up, we get 2x equals minus 15, and therefore we get x is equal to minus 15 over 2, which is perfectly acceptable. In fact, that's the preferred answer. Or if you really insist, you can write it as minus 7.5. Okay, let's go to our next example. Right, now, so in this example here we have an equation x plus 3 over 4 equals 2. Remember, it's still linear because my x power is 1. Okay, but what do we need to do? Well, firstly, and again, look, what I suggest with these videos, the best way of doing it, I reckon you should pause it now and have a go at this example. If you feel, yeah, I'd rather you just had a go and got it wrong, because it's great to go back and see where, oh, yeah, okay, I did that wrong, and off you go again. But it's really good to pause, get ahead, and then check. Really powerful. Okay, but what we're going to do here is I'm going to multiply both sides by 4. When we've got a fraction here, this denominator, I want to get rid of it, so I multiply both sides by it. And the effect is that we're left with x plus 3 here on the left, because multiplying this by 4 leaves us just with x plus 3. And we do the same to the other side. We go 2 times 4 is 8. Now, in reality, the way visually you'll see this is that this here, this x plus 3, will equal this here 2 times this here 4. And you can see how that works. 9 over 3 is equal to 3. Have a look at it. 3 times 3 is 9. 2 times 4 equals x plus 3. That's how you can visualize it and get on with these things quickly. Once we're at this stage, pretty straightforward, isn't it? We just want to take that plus 3 over this side, make it minus 3. So 8 minus 3 is equal to 5. And we've solved that one. Okay, I want to do 2 more. This one here, we've got fractions on each side. Slightly more difficult. But what I'm going to do is, like any fraction, and I'd again, get ahead if you can. Any sort of equation or expression with a fraction, we've got different denominators. It's different here. We've just got one denominator, so we can just multiply out. But here we've got 2 different denominators. Best thing I think to do is firstly get your denominators the same. So let's get them both over 6, and I know I can do that because 6 is the lowest common multiple of 2 and 3. Right, that's the LCM, lowest common multiple of 2 and 3. Right, I've changed 3 to 6, so I've times by 2 in the denominator, so I need to times by 2 in the numerator. Right, so I do that. The 6 from the 2, that's been tripled, times by 3, so I times the numerator by 3. And therefore, I haven't changed the value of either fraction, I've just rewritten them both over 6. Now they're both over 6. Have a look at this. What I can do now is just multiply both sides by 6, and the effect is I'm just left with the numerator on each side. So once the denominators are the same, you can remove them, get rid of them. So my 4x minus 2 is equal to my 3x minus 1. Okay, so therefore, just expanding out now, 8x minus 4 equals 9x minus 3. Now, which way should we go? I'm always going to take my x's to the side that keeps my x's positive. So I'll take my 8x over there, and that dictates my x's are going on the right, so my numbers have to go on the other side on the left. And the numbers are going to have to move sides. So on the left hand now, I've got minus 4, it hasn't changed. My minus 3 has become plus 3. On the right side, I've got 9x minus 8x. And all I need to do now, this value is x. And this value is minus 1. But you know what? We always like to write it with x on the left, don't we? So x equals minus 1 is my final statement there. Okay, now for our last example, we've got, okay, so in this case, we've still got fractions with 3 and 2 on them, but we've got this number here as well, just chiming in. Right, so let's think about it. Fraction, think straight away, common denominator. 6, isn't it? I'm even going to put my 4 over 6. All right, that's a bit of a strange thing, but I'll show you why in a minute. Okay, so what's happened? 3 has been doubled to 6, so I do the same to the top. Okay, we're just writing equivalent fractions here. 2's been tripled, so I do the same to the top. Times by 3. the 4. Right, so what's happened to the 4? Well, the 4 is 4 over 1, so the denominator's been times by 6. So the numerator gets times by 6, and 24 over 6 is equal to 4. Now that everything is over 6, we can remove the over 6 denominators. We're just left with the numerators. So I get 2x plus 2 minus 3, 2x minus 1 equals 24. Now we expand. Let's race through this. 2x plus 4 minus, let's be careful here, we've got a minus 3 out the front. Minus 3 times 2x is minus 6x. Minus 3 times minus 1 is plus 3. Be careful of that. Now what do we got? 2x minus 6x. So now we put our like terms together. 4 plus 3, and that's equal to 24. Now what I'm going to do here is the minus 4x, I'm going to pop it over this side to make it positive, which means the 24 comes back over here. So therefore, I've got 7 minus 24 on the left, and I've got 4x on the right. 7 minus 24 is minus 17, 4x is 4x. I'm now going to switch sides, divide by 4, and that's minus 17 over 4 as my solution. Okay, plenty for us to get on with now with exercise 1C. So we'll do that on Thursday in class. See you then.